Okay, everybody, so for today's video, I wanted to show you some additional problems on matrices and Cramer's rule, and that would make this video a follow-up to another video that I've already posted. Okay, so if you want to see some more examples, this is the place to look. So let's start with what I think is probably the hardest part about working with matrices, and that's learning how to multiply them. Okay, so let's say the question says multiply, or it may say find the product. Okay, but they mean to multiply either way you say it. And so I'm going to have this matrix. And what's a matrix? It's an array of numbers, 1, 5, 2, and -7. This matrix has two rows. The rows go horizontally, and it has two columns. The columns go vertically, so it has 4 numbers in it. So I'll take that matrix times this one. This matrix has 2 rows and 1 column, all right? And say the task for us is to multiply them. Well, so first, you can't always multiply 2 matrices together, all right? So the rule works like this. So I have a 2 by 2 matrix first. 2 rows, 2 columns, okay? And then I have a 2 by 1 matrix second. 2 rows, 1 column. Now, if I were to put the order of each matrix, that's what we call this, 2 by 2, 2 by 1. That's the order of the matrix, 2 by 2 for this one, 2 by 1 for that one. If I were to put those together, the way that these matrices are given, these interior numbers would have to match in order for multiplication to be possible. And if they do match, then the result is going to be this by this. So the result's going to be 2 by 1. Okay? So when I multiply these together, I'm going to get a matrix that's 2 rows and 1 column. So in other words, it's going to look like that. Okay? So all right, so that's what we're going to get. Now, how do we get there? So let's think about it for a second. And then maybe after you have some time to think about it, I'll tell you. All right, so I've updated this a little bit. So we're going to get a 2 by 1 matrix as a result. So 2 rows, 1 column. And the way generally, like no matter what we're doing when we multiply matrices, the way that we get the answer, whatever it is we take the rows of the first matrix times the columns of the second. Okay? And so here's the way it's going to work. This entry is going to be row 1 of this matrix times column 1 of this one. And remember, our result's 2 by 1, so 2 rows, 1 column. This one is going to be row 2 of the first matrix times column 1 of the second. Okay, so that's how we do it. Now, suppose now that I've told you that, I say, okay, well, how do you multiply row 1 times column 1? Now, it might be that every matrix multiplication problem is a little bit different, but every time we take the rows of the first one times the columns of the second. And what I mean by taking this row, row 1, times this column, column 1, is that we do something like this. Okay, so do you see that? I wrote the row here 1, 5 in pencil, and I wrote the column 1, 4 in my red pen. That's how you multiply this row by that column. I always think if I could pick this row up and turn it that way and set it right on top of this one, the 1s would align and the 4 and the 5 would align. That's what we do. We do 1 times 1 plus 5 times 4, which is what you see here. Okay? And the other one would work in more or less the same way. And see if you can think about what it is before I write it down. And there it is. So here, row 2 in pencil, 2 and -7. And then I wrote column 1 there in the second matrix in pen, 1 and 4. All right? So it's going to be 1 times 2 plus 4 times -7. Again, if I was to pick this row up and turn it that way, the 1 would be on top of the 2, The 4 would be on top of the -7. We would multiply those numbers and then add the result together. Now, that's just how you do it. I mean, you don't, are there other ways to explain this? Of course, there's lots of ways you could explain it, but no matter how you explain it or no matter how you end up doing it, you're going to be putting the numbers together that way. So you'll just have to, if you catch on with this pattern as I show it to you, that's great. If you kind of figure your own way to think about it, as long as you put the numbers together like that, that's how it's done, all right? So, well, all right, what are we going to get then? If I take 1 times 1 plus 5 times 4, that's going to be 1 plus 20. So this will be 21. And if I take 2 times 1 plus -7 times 4, that's going to be 2 plus -28. All right, so that's going to be -26. So there is your 2 by 1 matrix that is the result. 2 rows, 1 column, entries are 21 and -26. Okay, so that's one example of multiplying. For most people, it takes practice, it takes getting used to. That pattern here I'm trying to show you might not be real easy to see at first, but if you look at enough examples, if you practice it, then it's like anything, you'll learn to do it, all right? Let's look at another example, okay? So say we have this question. It says multiply, or maybe it would say find the product of this matrix 11, 5, which is 2 rows, 1 column, times this one, 4, 9, 3, -2, which is 2 rows and 2 columns, okay? So what was that rule that I mentioned? Okay, what are we doing here? So this first matrix, 2 rows, 1 column. Okay, so it's a 2 by 1. And we're multiplying it by this other matrix, which is 2 rows, 2 columns. Okay, so 2 by 2. And I said that this number would have to match that one in order for the multiplication to be possible. Okay, so I notice with that, well, they don't match. It's just as simple as that. And imagine if I tried to pick this column up and put it on top of that row, the numbers wouldn't align. Okay? Like in that last problem, they aligned, and here they don't. So there's no match this time. So if you came across this question and it was your task to multiply these, we would just have to say it's not possible. Or the answer choice may be that it's not defined or something like that. But, we don't go through the procedure because it's not possible this time. Okay. All right. So here I wanted to give you another look at that rule to tell if matrix multiplication is possible. If we had written it out like that and those interior numbers match, well, then you can go through the procedure, but not this time. Okay. Now let's take a question with a little bit different wording. So suppose that the question has like mixed parts to it, where each part you do something a little bit different. But in the beginning it says matrix A is this one, which is what? 2 rows, 2 columns. And matrix B is this one, which is 2 rows, 2 columns. Okay, so matrix A, matrix B. The first part says what is -2 times matrix A plus matrix B. Now, compared to multiplying matrices, taking a matrix times an individual number is pretty easy to do, okay? And adding 2 matrices together is also comparatively pretty easy to do. So here's the story on this one. That says -2 times matrix A. All that means is every individual entry in matrix A is multiplied by -2. So that's not so bad. You don't have to think about some pattern and turning things around and seeing how the numbers fit over each other. It's just that every entry here in A gets multiplied by -2. So what would that be if every single number here got multiplied by -2? I get -4, -2, -6, -10. Right? Is that true? -2 times 2, -4. -2 times 1, -2. So sure, that's -2 times matrix A. And I'm going to add matrix B. So let me put matrix B over here like this. Okay, and now I'm up to doing this. I want to add this matrix plus this one. Now, matrix addition or subtraction are both pretty easy to do. As long as these matrices are the same size, we can add them or subtracting just by adding or subtracting the corresponding entries. Like, you know, I'll do -4 plus 4. And I'm going to get a matrix of the same order back. It will be 2 rows, 2 columns. I'll do -10 plus 6. You see that? It's a fairly easy pattern, at least compared to multiplying the matrices. So, okay, so let's do that. -4 plus 4. All right, so that will be 0. -2 plus 9. That's going to be 7. -6 plus 7. That's going to be 1. -10 plus 6. That'll be -4. So there's our answer. First, I multiply matrix A by -2 uniformly, every entry. And then I take that result and I add it to this other one. So that's not too bad, I would say. Multiplying is a little harder. So the second part of my question says, well, can you calculate matrix B times matrix A? All right, so let's see. Matrix B, let's write it out like this. That was 4, 9, 7, and 6. Right? Times matrix A. All right, so that's going to be 2, 1, 3, 5. Okay. Can these even be multiplied? You know, sometimes it's not possible to multiply matrices. They don't align with each other correctly. So we need to write the size or the order of each matrix down and see if those interior numbers agree. So this time it won't be a problem because what's this one? 2 rows, 2 columns, right? 2 rows, rows go horizontal, columns go vertical. And this other one, also 2 rows, 2 columns. So yes, these interior numbers do match. So this multiplication is doable. And I'm going to get, as a result, another matrix that's 2 rows by 2 columns. Okay? All right. So now that we know it's doable, and now that we know what our answer is going to be like, how do we do it? Well, generally, when we multiply matrices, we take the rows of this one times the columns of this one. Okay? The rows of this one times the columns of this one. All right. And we'll proceed as follows. We'll take row 1 times column 1, row 1 times column 2, and so on. Now, think about if I were to write like a formula. Can you imagine what it would be? And there it is. Okay, my 2 by 2 matrix, that's the result. 2 rows, 2 columns. The 4 entries are going to be row 1 of the first matrix times column 1 of the second. Then this one, row 1 of the first matrix times column 2 of the second. And then this entry, row 2 of the first matrix times column 1 of the second. And then that one is going to be row 2 of the first matrix times column 2 of the second. Now, if you really want to pick this apart and make it even more general, notice that in my answer, each result is obtained from row 1 of the first matrix. And in this row, each result is obtained from row 2 of the first matrix. And in this column, each result is obtained from column 1 of the second matrix. And in this column, each result is obtained from column 2 of the second. Okay, so that's yet another way to think about it. All right, I'll try to tell you different ways without overdoing it, but you know, I have to consider that different people might prefer to think about this different ways until they catch on to the pattern. So, all right, now say I was to do that, you know, what if you could pause the video for a second How would it look to do row 1 times column 1 and row 1 times column 2? Like, would you be able to fill that in before I could? And there it is. 4 and 9, that's the first row right there. 2 and 3, that's the first column. 4 and 9, again, that's the first row. 1 and 5, that's the second column. Okay. All right, so that's the math for this. As far as the numbers go, there we could use our calculator if you don't mind doing math in your head. You could do all that in your head, but you got to multiply 4 times 2, that's 8, and 9 times 3, that's 27. You add them together, okay? All right, so we'll get 35 for this one. Okay, so 27 plus 8. And then here we'll get 49. Okay, because that's 45 and 4. 18 and 14, that's going to be 32 right there. And then 37. All right, so there's our final 2 by 2 result. Okay, now from here, even if you were to find a problem where these were different sizes than what I have here, like that, say they weren't 2 by 2s, or maybe they were 2 by 3 or something like that, you still take the rows of this one times the columns of this one in much the same way that you see here, even if the problem looks a little bit different from the start. In addition, R1 is going to be in the first row, R2 is going to be in the second in your answer. C1, column 1, is going to be in the first column. C2, column 2, is going to be in the second. So even if the problem was a little bit different, those, general ideas would still be true about how you work it, okay? But it'll take some practice on your part. So anyway, all right. So we did some matrix multiplication. The last thing that was on my mind for this video was a few other examples of Cramer's rule. So I had an example that I thought would be pretty easy that I'd like to show you just to get you thinking about it. And then I wanted to do something that looked a little bit harder, okay? All right, so let's start with this one. And at this time, this is not the first time I'm explaining Cramer's rule to you. It was in that other video, okay? I just wanted to go in a little more depth with this one. But one thing I showed you is that you can solve for x or y in terms of these things called determinants, okay? So here's how you can solve for x. First of all, your problem needs to be arranged that the x's are together in the first column. The y's are together in the second column. See? There's an equal sign, and then you have these numbers, -1 and 3. So it needs to be arranged like that from the beginning, okay? Now, here's what we do. We take these numbers on the left-hand side of the equal sign, and we put them together this way. All right, so 2, 3, 1, -6. I keep them in the arrangement that they were in, and then I put these vertical bars around them. And this thing right here is called a determinant, if you would like the vocabulary, that's what it's called. It kind of looks like a matrix, but it's not the same thing. In math, there's lots of symbols, and part of learning to do math is to learn to read all the symbols and not get too intimidated by them. A matrix has these, kind of like these square brackets to enclose the numbers, all right? But a determinant, which looks similar, has vertical bars. All right, so this is not a matrix. It's not the same thing. Now, that's what I put on the bottom. And I have this fraction. I've got this fraction bar. On the top, here's what I do. I take this determinant, but if I'm solving for x, in the first column, I write these two numbers in the order they're given in place of that first column. So imagine if I took this matrix, see, look at that, this determinant, and in place of that first column, in place of the numbers that are there, I put a -1 and a 3. So like that. But I leave this one the same, 3 and -6. All right. So there, that would be it, okay? This would solve me for x. And I put that in red because I wanted it to stand out that I took this and I just replaced that first column with these numbers on the right-hand side of the equal sign. Like everything in this section with matrices, there's a pattern to it. Now, all right, what's a determinant? A determinant is a calculation. These vertical bars here that indicate that these are determinants are instructions to do something. Here's how you evaluate a determinant, this like this. We take this number times that one. Okay, so -1 times -6, we multiply diagonally like that, and then we subtract this number times this number. They're always done that way. This times this minus this times this. -1 times -6 minus 3 times 3. And then that's just calculate. It's 6 minus 3. Or 6 minus 9. 1 times 6 is 6, 3 times 3 is 9. This one down here is done the same as that one up there because they're both determinants. So they might have different numbers, but they're done the same way. So 2 times -6, remember, because I multiplied diagonally like this. And then I subtract in 1 times 3. All right. So this is the formula in the form of these things called determinants. And then here's the math. So what did we say this one was? 6 minus 9. That's going to be -3. And then this one is 12 minus 3, right? 2 times 6 is 12. 1 times 3 is 3. So that's going to be -15. So my answer there will be 3/15, or 3/15. So if you solve for x, you'll get 3/15. Okay? So there's your answer. What's the x supposed to be? The x is supposed to be 3/15 in order for this to be right. What about the y? Well, so Cramer's rule can be used to solve for x or for y. We just make one adjustment to solve for y. The bottom part is the same, whether you're solving for x or y. That means that the bottom part is going to be the determinant 2, 3, 1, -6. Okay. The top part, the determinant up there will be different if you're solving for x versus y. So kind of think about like this. If you're solving for x, you replace the first column. If you're solving for y, you'll replace the second column. You'll take this and you'll replace the second column with what? The numbers on the other side of the equal. So it'll be -1 and 3. So if I took this, I replaced the second column with -1 and 3, and then I leave that one the way it is, because I'm taking this and I'm replacing the second column. It's going to leave me 2 and 1 right there. All right, so now to calculate any of these determinants is not going to be different. This one is done the same way as this one, is done the same way as this one. We don't need to do this one again because there it is, and we got -15. What about that one? Well, you do them the same way all the time. 2 times 3, multiply diagonally this way, minus 1 times -1. 2 times 3 minus 1 times -1. So what's that? So that's 6, and then that's going to be a +1, so that's 7. So we'll get -7/15. Okay. All right. Now any equation that you solve, it can be checked. So I'll challenge you to this, especially if you have a calculator. If you take 3/15 and put it for x, and -7/15 and put it for y, you'll get -1. It will be correct. It will be true. That's what it means to solve it. We get numbers that work. And if you put 3/15 for x there, and you do -6 times -7/15 there, you'll get 3. You could verify that these are correct, like any solution. Now, I want to show you this one just to get you thinking the right way. Here's one that is a little bit harder. It's not that hard, but it is a few steps beyond the last one. Remember when I started the last problem, I said I need it to be arranged in a particular way. I need the x's in this column the y's in this column and numbers in this column. All right, x plus or minus y equals numbers. It's got to be like that. And if it's like that, you just feed all the numbers into the formulas. Now, this one is not arranged that way. So, I'm thinking that in order to use Cramer's rule, I need like x, y equals a number, and x, y equals another number. Now, there will be like coefficients and pluses and minuses, but it's got to look like that. I've got to rearrange it that way. Okay? So how are we going to get from here to here so that we can use Cramer's rule? Well, I see parentheses in a certain way, and we know how to deal with those at this point. We do like this, right? You distribute. We take 0.1 through there and 0.2 through there. Okay, that's one way you could do it. It's not the only way, but I think that's the way most people would think of. So that's how I'll show you. So if we do that, we'll get 8.3. And I'll multiply 0.1 through there. I'll get 0.9y minus 0.4x. Okay? And if I do that with this other one, let's see, I got 1.4y over here. And I'll take 0.2 times 77, so that's going to be 15.4, negative 15.4. And then 0.2 times negative 7x, so that's negative 1.4x. Now, I'm a little closer, but I'm not there yet. I need this x and that y to be over here on the left-hand side, and I need that number to be over here on the right-hand side. And I need this x to be over there, and I'll leave that number where it is. So what I could do like this. I could subtract the 0.9y and add the 0.4x. So by now you've seen how you can add or subtract the same thing to or from both sides of the equation. If we do that, then here's what we'll get. We'll get 0.4x. To move this to the left, it will become positive, minus 0.9y equals negative 8.3. Okay, now I've got x, y equals sign number. That's what I was going for from the beginning. And then this next one, I got to move this negative 1.4x over there. So I get 1.4x plus 1.4y equals negative 15.4. Now this is the way I needed it to be arranged. I have the x's in one column, y's in the next, an equal sign, then the numbers, okay? That's what I was telling you I had to get out of it. But I had to do some pretty basic things to get there, but it needed to happen. All right, so now that it's arranged correctly, we just put the numbers into this formula. So what's the formula? It involves determinants. What goes down here? The numbers on the left-hand side of the equal sign in the arrangement that they're given. So 0.4, negative 0.9, 1.4, 1.4. Okay. And then what goes up here at the top? Well, if we're solving for x, we'll replace the first column of this one with those numbers. So negative 8.3, negative 15.4. All right. And then that's not going to change these two. All right. And now we multiply in the same way as before. Okay, so you saw me do the other problem. I want to see if you can get this one, so maybe pause the video. Calculate these determinants the same exact way that you had it in the last problem. See what you get, and then I'll tell you. All right, so that's what you'll get right there. Negative 25.48 on the top and 1.82 on the bottom. If you divide those, 25.48 divided by 1.82, so then you'll get 14 negative. Negative 14 is x. Okay? Now, the y wouldn't be any different than it was for this problem. Same pattern, same everything. We just had to get it to this point, all right? Once we got there, we can use Cramer's rule. So I'd like you to try to do the y yourself, and if you get it, then that's good. You should get 3, okay? All right. If you solve for the y with Cramer's rule the way you're supposed to, 3 is the answer you'll get. And if you get 3, then great. You understand the pattern and you do the math correctly. If you can't get the 3, then we'll talk about it. I can go through the example with you, and I think you'll understand it then. But at least for now, try to do it by yourself.